Hi, welcome to the first official AP Calc series where I cover just all of the different units as well as their basic sections. Today we're going to talk about Unit 1, Limits and Continuity, especially with the definition of our limits. Our goal is to understand these two things, to eventually understand what this is called, the limit as h approaches to 0 of this entire fraction that we see here, but our main goal in overall this unit is to understand this, that the limit as x approaches to a of f of x equals to L. I want to begin just kind of starting just the idea of the limit definition through this. Why are we doing this? The main reason why we're doing our limits is to figure out this first box. It'll eventually come, but for now, it's just some random equation. Our whole goal is to understand these things called tangent lines. If you can see here, we have our function y equals to x squared. We have different points. We have example 1, 1. Our whole goal for today is to figure out how to know this tangent line. So you can see here I drew it in yellow. This is what we call a tangent line. A tangent line is basically the line of the function touching at exactly one point. Now our goal is to figure out how to figure out this tangent line. But in order for us to do that, well, we need to figure out the slope, right? Just to recall, like, how do we figure out slope? So for slope, we can define it as this. We can define it as y2 minus y1, x2 minus x1. And we define that by m. And so if I look here, I don't really know my slope yet. And so I'm just going to pick some maybe some points along this parabola, y equals to x squared. And maybe what I can do is I can probably make some tangent lines that look pretty close to it and then eventually shift our way through. So here, for example, this white line can be almost like our tangent, but not really. As we'll go and kind of see, eventually I get closer and closer. So for example, here, right, that's like a random dot I put here on the right. But as I continue to go on, maybe somehow in some way, this line, these white lines that I'm making, will eventually become the yellow line. So here's a second one I'm drawing. And you can see here, this second line, as we kind of get closer, looks a little bit more like the yellow. And so let's try to figure that out. Since I'm choosing random points along for my white line, I'm going to label them as x comma x squared. We don't really know what they are yet, so we'll just default to that. We also have our point 1, 1, and so what we're going to do is we're just going to label those 2 points. This is our first, and the second one, 1, 1. Since we're talking about slope, I'm just going to write it down. So I'm going to say that the slope is y2 minus y1. So I can say that's x squared minus 1 over x minus 1. Okay, so I have that. And maybe what I can do is I can try to find our slope through just plugging in different points. So say, for instance, I just plugged x equals to 2. If I plug in x equals to 2, that would just give me the following, that m is equal to 2 squared minus 1 over 2 minus 1. This gives me 3 over 1, which is 3. And so maybe that could be a good estimate. I can say the slope at 2 and 1, 1 is 3. But let's see what happens, because maybe that could be for this line. But you can see here, as we go a little bit closer to 1, something changes. The slope changes. So let's just say I did like maybe in between 1 and 2. So let's just say 1.5. Well, I'm going to do it again. So I'm going to say m equals 1.5 squared minus 1 over 1.5 minus 1. And luckily, through previous calculations, we get 2.5. Okay, so that's interesting. It's the slope is getting like a little bit less and less, which kind of makes sense. I can kind of see that. It's getting a little bit more flatter. Let's just maybe do a little bit closer to 1. So maybe let's go really close. Let's just say it's 1.1. Let's see what happens. Again, I'm going to plug it in. So I'm going to say m equals 1.1 squared minus 1 over 1.1. Again, I already pre-calculated these. And so we can see here, this is going to be 2.1. Again, notice what happened. It got a little bit more flatter, right? The slope is getting less and less. Okay, so maybe let's just even do a little bit closer to 1. Let's just say 1.01. So oddly close to this 1, 1. If I do that, let's see what happens. Again, plugging it in, 1.01 squared minus 1 over 1.01 minus 1. Again, through sheer calculations, I get 2.01. So you might be starting to notice this pattern. As x is decreasing, or as x is going to 1, what are we noticing? Well, we notice that our slope is getting obviously smaller, but it's getting to an oddly specific number. So I think we can make a guess if I do it one more time. Let's just do one random shot. If I do 1.001, being really close to this, if I do that calculation, I just put this all in my calculator, what do I get? If I put this all in my calculator, I get 2.001. This probably tells us a big sign. It's getting really close to this one number. And we can say that as x is going to 1, our slope is going to 2. And so that was the whole point of this. And luckily, as we were kind of just doing this, this leads us to our first goal. Like, why are we trying to do this? It's because we're noticing as we get closer and closer to this number, we're getting closer and closer to a value. And matter of fact, this eventually leads us to something that we'll learn later on, but the limit as x approaches to 1 of our function, so we say f of x plus h minus f of x over h, and we can actually say this is going to be h approaching to 0. This, for our case, would be 2. Or we can also write it like this, that the limit as x approaches to 1 of the slope, which is x squared minus 1 over x minus 1, it approached 2. Seems really complicated, but I hopefully just want you to understand that you notice that we can just plug in smaller values, and we can kind of see that as we get closer and closer to the number we're looking for, 1, 1, that it goes off to a specific value. So this whole first activity was just trying to explain this first part. But now let's talk about the second part, the true definition of a limit. This is the limit definition. And I kind of wrote the English here. The limit of f of x as x approaches a equals to L. So you can kind of see here in our graph, the whole thing I want you to focus on is you just see that as x approaches to a, so I'm going to just draw like arrows to the right and to the left. As x approaches to a, you can see that in this graph in particular, we can see here that as x approaches to a, it's approaching this y value that we call L. You don't know what L is, but for the most case, we can usually see it on the graph, and as well as the function. And we're going to do this example, kind of doing the same basic thing. So here, we're going to find the limit as x approaches to 1 of x plus 1. We're going to see what that is. Kind of like what we did before, let's just try doing like numbers closer to 1, and we'll try that out. So here, I'm just going to put maybe an x versus an f of x table. So I'm going to put maybe 2, then 1.5, then maybe 1.25, and I'll keep on going. So in this case, our function is x plus 1. And so if I'm just going to plug it in, let's see what happens. This becomes 3. This becomes 2.5, because 1.5 plus 1 is 2.5. This is 2.25. Okay, so we're noticing it's dipping it down again. I'm going to try it again. So I'm going to say what happens if it's 1.001. If I plug that in, that's 2.001. And then if I even tried like the other side, so let's just say I tried maybe like 0.99 or 0.9999, I get 1.99 for that one, and then for the second one, I get 1.999. So if you're kind of noticing, both on the left and the right side, it's clearly approaching this number. It's getting oddly close to one thing, and we can see that that value is going to be 2. And so we can just make this claim that the limit, as even just from the table, that the limit as x approaches to 1 of our function x plus 1 gives us 2. And we're eventually going to see that later on, instead of doing this table, that we can just do this by just simply plugging it in. So we can just take this, and we can just say, wait, this was just 1 plus 1, which is 2. But that's the whole definition of our limits, that we can just see that as we go closer and closer to our value, it gets closer and closer to a y value, which we call L. And that's basically it.